So now let's try some of these on our own, now that we went through the practice problem. So step number 1, the minute I see a radical, I say, is that radical isolated? Yes, it's all by itself on the left side of the equation. It is isolated. So I'm going to go ahead and write bigger over here just so it's easier for you to see. So step 2 is undo that radical. Well, it's a square root, so I can undo it by squaring. But whatever I do to the left side of the equation, I also must do to the right side of the equation. So as we discussed on the example problems, these undo each other because squaring and square root are opposites. It's like adding something and then subtracting it. They're opposites. Square root and square opposites. So what happens is 3q minus 2 will pop out of the radical because I have 2 of them. So 2 things pop out of the radical, and it's equal to 4. And then I just solve like normal. I can see this equation does not need to be set equal to 0 because there's not a squared on the q. So this is just solve the equation. So anything without a q moves right, anything with a q stays on the left. So 3q equals 4 plus 2 is 6. Divide both sides by 3. And we get our potential solution as q equals 2. So now we need to do the check. And remember, every even index has to be checked. So I cannot put that in solution sets until I check it. So write your original equation. 3q minus 2 equals 2. And then plug your 2 in. So when I plug the 2 in, I get 3 times 2 minus 2. Is that equal to 2? So 6 minus 2 is the square root of 4 equal to 2. Boom, we got our solution. Yay! So then we take our solution and put it in solution sets to show that it's valid. So as long as this is a true statement, just like above, 7 equals 7, true, 2 equals 2, true, we put it in solution sets. If it provides a false statement, 1 does not equal negative 1, then we leave it out of solution sets. So this one has a solution of 2. So let's go ahead and box that just to make it easy to see. Okay, so ready for another one? Hopefully the answer is yes. By the way, 1 is on the test. It is just like number 19 on the practice test. Number 2 is on the test. It is just like number 21 on the practice test. And the real test. So to start off with, I don't really like having my radical on the right. I like it on the left. It just is confusing to me. So the first thing I'm going to do is flip the equation around. So 4x minus 15, square root of all that, equals x minus 5. So notice the radical is all by itself. There's no numbers, signs, anything outside the radical. So step 1's done. Step 2, remember, is to square both sides. But in order to square both sides, look what we have here. Do not distribute that square. This is 2 terms, which means this is a FOIL problem. So out here to the side, if you want to write that to get ready to FOIL, that would be a really good idea. So don't distribute that too. Like I said, you'll miss every one of these on the test if you're still doing that way back from chapter 4. It's write it out twice and FOIL. So this side though, no work needed. Those two undo each other and we just get 4x minus 15. This side, though, we're going to have to FOIL, so we get from f, x squared, from o, minus 5x, from I, minus 5x, and from L, plus 25. Notice we had to do the whole FOIL on this. These are not conjugates, so we have to do all 4 steps of FOIL. So we have 4x minus 15. Let's combine like terms on the right. X squared minus 10x plus 25. Any alarm bells going off? This tells me what? I can hear you. Set equal to 0. The minute you see that x squared, set equal to 0. So I'm going to flip this equation over. So my x squared's on the left. So x squared minus 10x plus 25 equals, and then here I'm going to have 4x minus 15 on the other side. So since I know I have to set it equal to 0, that means I have to do the opposite to bring this left, do the opposite to bring this left. So the opposite of positive 4x, negative 4x. Put it underneath its like term. The opposite of negative 15, positive 15. Put it underneath its like term. Then I'll get x squared minus 14x plus 40 equals gone, so there's our 0. That was our goal. Anytime there's an x squared, that means it's a factoring problem, and you can't factor until it's set equal to 0. So now we have a problem straight out of chapter 4. Once it's set equal to 0, you say, what kind of factoring? Oh, it's a trinomial with leading coefficient 1, so it's double bubble. And we know the plus sign at the end means the signs are going to be the same. And we also know this means they're both going to be negative. Next, we have factors. Well, let's go ahead and put in our signs. So we know they're both going to be negative. So we're looking for factors of 40 that add to 14. I don't have to look at 14's sign. I already have those there. So factors of 40 that add to 14 would be 4 and 10. So I put those in. And then just like we did in chapter 4, if A times B equals 0, either A is 0 or B is 0. Solve both and you get 2 solutions, potential solutions, x equals 4 or x equals 10. Now we're ready to check. It is an even index, so we do have to check. So let's write our original equation here. X minus 5 equals square root 4x minus 15. And let's label this as our check, so when you're looking back at it, you don't think it's a continuation of the problem. So first we're going to put 4 in for both of these x's. So 4 here and 4 here. If it's a true statement, then 4 is a valid solution. So 4 minus 5. Does that equal 4 times 4 minus 15? Does negative 1 equal 16 minus 15 square root of 1? Nope, negative 1 does not equal 1. So that means 4 is an extraneous solution, so we can go up and cross it out. So 4 minus 5 is negative 1. 16 minus 15 is 1. The square root of 1 is 1. Negative 1 does not equal 1. Therefore, 4 is an extraneous solution. Now we have to put 10 in. So let's change these 4's to a 10. So 10 minus 5. Does that equal 4 times square root of 4 times 10 minus 15? 10 minus 5 is 5. 40 minus 15 is 25. Is that a true statement? Ding, ding, ding. Yes, it is. That means that 10 is our one and only solution. So 4 was an extraneous solution because it didn't check. Let's just put a double arrow there. And 10 did check, therefore it is our valid solution. And yes, I did put 2 long problems like that on the test. It's the whole back page of your test. So you have 2 problems to work and then the bottom of the page to do the checks. So there are 2 like that on your test. I'll have you mark another one later. But that is definitely one you want to work through again. Maybe do your practice test. Go to your practice test after the lesson and make sure you can do those. Number 3 is also on your test. It is just like number 20. So lots of test questions. So this is test number 20. We're not going to do 4, by the way. It's a really ugly problem. So if we need more room for 3, we can move down there. Okay, so step number 1, isolate the radical. Hopefully you notice on this one the radical is not isolated. There's a number outside. And you have to remember this means times. So to get rid of that number, if it was a plus sign, we'd subtract. But here we know there's an imaginary times sign, so we're going to divide both sides by 2. So that leaves us with cube root. So 2's are going to cancel. 4x minus 5 equals 4. Okay, now our radical's all by itself, nothing's outside, so that means it's time to undo the radical, which means cube both sides, because notice on this one my index is 3. I should have done that in a different color. Let me do it I'll do it in black, just so it looks different. So to undo a cube root, we cube both sides. The cube and the cube root are going to undo each other, so that 4x minus 5 just pops out of the radical. On the other side, we get 4 times 4 is 16 times 4 is 64. Or you can do that on your calculator, of course. I notice there's no x squared term, so because there's no x squared term, I don't have to set it equal to 0. I just get x alone. So move everything without an x to the other side. So 4x equals 69. Divide by 4, x equals 69 over 4. That one might be nice to turn to a decimal just to make it easier to check. So get your calculator out, and I know it's a nice decimal because whenever you're dividing by 4, it's nice. So 69 divided by 4 is 17.25. Remember, on cubes, you don't necessarily have to check them, but since we're just new with the whole checking thing, I think it would be a really good idea to check. So, over here, let's write our check. And this one we're going to mostly do on our calculator. So go to the original problem, 2 cube root 4x minus 5 equals 8. And in place of x, we're going to be plugging in 17.25. So, get ready for the calculator. 2 cube root 4 times 17.25. And then we still have our minus 5. We want to know, does that give us 8? So we know that 17.25 times 4 is 69 from over here. So this is 69 minus 5, and you can just plug it in your calculator if you like. So 69 minus 5 is 64. We want to know, does that equal 8? So cube root 64, 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. And remember, this is an imaginary time sign, so we want to know, does 2 times 4 equal 8? Ding, ding, ding. Yes, it does. So we can go over here and we can write 17.25 in solution braces, or we can write 69/4 in solution braces, or we could write 17 1/4, which would be the most awkward way. But any of those will work.